Hi class, today we're going to continue on with the respiratory system and we're going to focus on other aspects of the respiratory system such as respiratory volumes and capacities, movement, and different sounds. This is actually a pretty short section, but it's full of a lot of information, so make sure that you're keeping up with it and not confusing these terms. I would highly suggest making flashcards to help you study for your test coming up later this week. So there are factors that affect respiratory capacity, or basically how much air are you able to hold within your lungs. This can be size, sex, age, physical conditioning, etc. A good example of this is age. Usually about adulthood, you reach your highest peak of respiratory capacity, and then as you get older in age into your 60s, 70s, and 80s, this usually declines. Another example of this is physical conditioning. The more you are physical conditioning, the better chance you have of making your respiratory capacity larger. The first type of volume we are going to talk about is known as tidal volume, which is abbreviated TV. This is the volume of air that you take in and release when you are just normally breathing sitting down. It is not it's not loud, it's not obnoxious, you're not hypoventilating. It's normal quiet breathing. This is about 500 milliliters of air that moves into and out of your lungs with each breath. From there, we have something known as IRV and ERV. IRV is inspiratory reserve volume, or basically, this is other air, the amount of air that you can take in over your tidal volume. So, this is more air that you can breathe in. So, if you just breathe in normally, you can still continue to suck more air in, and this is usually about 3,100 more milliliters of air. Expiratory reserve volume, or ERV, this is what you breathe out after tidal expiration. And in both of these, one thing I do want to underline is forcibly. These are not passive processes anymore. You actually have to require energy to make sure that you suck in that extra air or you release that extra air. For ERV, this is approximately 1,200 milliliters. Then we have what's called residual volume. If you have residual volume, that is basically left over. Residual effects are effects that happen after you're sick or after. This is the air remaining in your lungs after you breathe it out. You actually cannot voluntarily exhale this air. The reason is it's very important because it allows gas exchange to go on continuously even between breaths. You constantly want your cells to have oxygen, and another thing is that this keeps those alveoli in your lungs open and inflated so they don't collapse. It helps maintain pressure. This is about 1,200 milliliters of air. Then we have vital capacity, which is abbreviated VC. This is the total amount of exchangeable air. So think about total. This is going to be adding. So we want to find the sum of some air. It is actually vital capacity is the sum of your tidal volume plus your inspiratory reserve volume and your expiratory reserve volume. So how much total can you breathe in and how much total can you breathe out? For men, this is about 4,800 milliliters, and for women, this is about 3,100 milliliters. So often, men have a higher respiratory capacity than women. The next one we're going to learn about is called dead space volume. So this is just air that remains in your conducting zones and actually never reach your alveoli in your lungs. So remember, your conducting zone are going to be things like your pharynx, your larynx, your trachea, even your bronchi. So this is just air that's in those different passageways that aren't necessarily all the way to your lungs. This is about 150 milliliters. And then you have what's called functional volume. And this is the air that actually reaches your respiratory zone and are still there. So again, your respiratory zone are things like your terminal bronchioles, your alveolar ducts, even your alveoli in your lungs. This volume is usually about 350 milliliters. Now, these respiratory volumes can actually be measured, or these respiratory capacities can be measured using something called a spirometer. So here is an example of a graph of various respiratory volumes in a healthy young adult male, and it kind of shows you these different volumes that we have. So here, an adult male, our total lung capacity is 6,000 milliliters. From there, you can break it down into your vital capacity. So remember that's your VP. Your vital capacity is your tidal volume, which is down here in the middle, plus your IRV, plus your ERV. And notice how it accompanies all of those. So here, your tidal volume, this is what he's breathing in a normal, quiet breath. Inspiratory volume, this is how much more he can suck in. And expiratory volume, this is how much he can forcibly breathe out after a normal breath. And residual volume, this is what's going to be left in the lungs or in those passageways afterwards. Next, we're going to talk about non-respiratory air movements. Now, in many situations, other than breathing, moves air into and out of your lungs. These can be caused by reflexes, such as a gasp, or voluntary actions that you can do. So some examples of them are things like coughing and sneezing, crying, laughing, hiccups, yawns. All of those are going to bring air into and out of your lungs. For example, cough and sneezing. This actually helps clear your lungs of debris and or mucus. Crying, this is actually an emotionally induced mechanism, and usually often when you cry, you're trying to catch your breath, you're sucking air in. Laughing is similar to crying. It's also emotionally induced. When you're laughing, sometimes you laugh so hard, it's hard to catch your breath, and sometimes you start breathing heavier. Hiccups are sudden inspirations, or basically where you suddenly breathe in, and this occurs because of spasms occurring in your diaphragm. Usually, the sound from a hiccup results from the air you're breathing in hitting your vocal cords. And a yawn is a very deep inspiration, or you're very deep breathing in. And actually, on the next slide, I'm going to actually highlight and have you add something. Here, this is a picture taken from your book outlining the movements and the mechanism and what it results in. For example, here we already talked about a cough. Here it defines it. Taking a deep breath, it closes the glottis, that opening, and it forces air superiorly from your lungs out. Um, and coughs act to help clear those respiratory passageways. Sneezes, though, they expel air directly through your nasal cavities instead of through your oral cavity. Crying, this is followed by a release of air and a number of short expirations. So you breathe out in very short, rapid responses. One thing I do want to add to your notes when you read through these is a yawn. Yawning actually ventilates all your alveoli in your lungs. Next thing we're going to talk about is respiratory sounds. So sounds, if you go to the doctor, this is one of the things they have you check whenever you get a checkup. They put a little stethoscope up into your chest region, and they ask you to take a deep breath in and a deep breath out. And then they go to your back and they listen to your breathing sounds from your back as well. Now, there are two recognizable sounds that can be heard with a stethoscope. The first one is your bronchial sounds, and this is produced by air rushing through those large passageways, such as your trachea and your bronchi. And the next one, the second one, is the vesicular sounds. These are soft sounds, and this is produced by air filling your alveoli within your lungs. Now, respiratory sounds can actually tell you if something is wrong or if you have a homeostatic imbalance. Diseased respiratory tissue, mucus, pus can produce abnormal sounds, such as if you have a bubbling sound that's described as a crackle. A whistling sound says that you are wheezing, and an abnormal bronchial sounds produced by either mucus or exudate in the lung passages or by the thickening of the bronchial walls is known as rales. And these sounds are often sounds that something is wrong with your respiratory tissue, even your mucus or pus. So that's the end of today's lesson. It's very short and sweet. Let me know if you have any questions, and I'll be more than happy to help. And I hope you guys have a good day.